Hello everyone. In today's lecture we will discuss delta to star transformation. In solving networks having considerable number of branches by the application of Kirchhoff's laws, one sometimes experiences great difficulty due to a large number of the simultaneous equations that have to be solved. However, such complicated networks can be simplified by successively replacing delta meshes by equivalent star systems and vice versa. So let us now try to understand what do we mean by delta connection and star connection. For this, let us consider the figure 1 and figure 2. If we are given three resistances R12, R23 and R31 and they are connected in this fashion, then it is called delta connection of resistance. That is, if the resistance R12, R23 and R31 are connected between the terminals 1, 2 and 3 in this way, then it is called delta connection. That is, in delta connection, one end of the resistance R12 is connected to R31 and the other end of the resistance R12 is connected to R23. Similarly, one end of the resistance R23 is connected to R12 and the other end of the resistance R23 is connected to R31. And the one end of this resistance R31 is connected to R12 and the other end of the resistance R31 is connected to R23. So, if we are given three resistances R12, R23 and R31 and they are connected in the delta fashion between the terminals 1, 2 and 3, then we can say that this is connection is called the delta connection. So, if these three resistances can be replaced by the three resistance R1, R2 and R3 which are connected in star between the terminals 1, 2 and 3, then we can easily convert the delta connection of resistance to star connection. So as it is clear from this figure that in star connection, when one end of each of the three resistance is commonly connected at one point, which is called the neutral, and the other end of each resistance is free. So this type of connection is called the star connection of resistance, or it is also called the Y connection. So I hope it is clear that in star connection, if we are given three resistance R1, R2 and R3, then one end of R1, R2 and R3 will be common at one point, which is called the neutral, and the other end of each of these resistances free. Then this type of connection is called star connection or Y connection. Similarly, if we are given three resistance R12, R23 and R31, then one end of each of the resistance will be connected to the one resistance and the other end will be connected to some other resistance. So if the resistances are connected in this manner, then it is called the delta connection of resistance, and if the resistance are connected in this way, then it is called the star connection. So we can easily convert the delta connection to star connection, and similarly star connection can be converted to delta connection. So according to our need, we can convert the delta connection to star and star to delta. So if the two arrangements are to be electrically equivalent, then it means that the resistance as measured between any pair of terminals should be the same in both the arrangements. In this lecture, we are discussing the delta to star transformation. That is, we are given the circuit in which the resistances are connected in delta, and we are interested in converting it to star. That is, we are performing the delta to star transformation. So for this, let us consider the delta connection as shown in the figure 1. So in the figure 1, we find that between the terminals 1 and 2, we find that there are two parallel paths
one path is having a resistance of R12 and the other path is having a resistance of R31 plus R23. So the equivalent resistance between 1 and 2 will be the parallel combination of R12 and with R31 plus R23. So the resistance between the terminals 1 and 2 will be the parallel combination of R12 and R23 plus R31. So if the resistances are connected in parallel, then the equivalent resistance comes out to be R12 into R23 plus R31 divided by R12 plus R23 plus R31. This is in accordance with the parallel connection of resistors, because we know that whenever two resistors R1 and R2 are connected in parallel, then the equivalent resistance is obtained by the formula R1 into R2 plus R divided by R1 plus R2. So in this way we can find the resistance between the terminals 1 and 2, which is equal to R12 multiplied by R23 plus R31 divided by R12 plus R23 plus R31. Now let us consider the star connection. So in star connection, the resistance between the terminal 1 and 2 will be equal to R1 plus R2. So we have taken the star connection, and in star connection we find that the resistance between the same terminals 1 and 2 comes out to be R1 plus R2. Now if the two arrangements are electrically equivalent, it means that the resistance as measured between any pair of terminals should be the same. So because the terminal resistance have to be the same, it means that the resistance obtained in star connection between the terminals 1 and 2 should be equal to the resistance obtained between the terminals 1 and 2 in case of delta. So we have equated both these. So we get R1 plus R2, which is the equivalent resistance in star between the terminals 1 and 2, should be equal to the equivalent resistance between the terminals 1 and 2 in case of delta. And let us call this equation as equation number 1. In a similar way, we can write the equations for the terminals 2 and 3 and for the terminals 3 and 1. That is, just as we have written the equation for the terminals 1 and 2 in case of delta and star, in a similar way we can find out the resistance in case of star, which will be equal to the resistance in case of delta. So this equation is for the resistance between the terminals 2 and 3, and similarly we can write the value of the resistance for the terminals 3 and 1, which we get as R3 plus R1 is equal to R31 into R12 plus R23 divided by R12 plus R23 plus R31. So we find that we get 3 equations. Now we are subtracting the second equation from the first equation, and the result is added to the equation number 3. And if we simplify it, then we obtain the values of the new resistance in star. That is, we will obtain the equations for the resistance R1, R2 and R3. And we find that the value of R1 will be equal to R12 into R31 divided by R12 plus R23 plus R31. Similarly, the value of the resistance R2 comes out to be R23 into R12 divided by R12 plus R23 plus R31. And the value of the resistance R3 comes out to be R31 into R23 divided by R12 plus R23 plus R31. Figure 3 shows how we can convert delta connection to star. So we find that this is the delta connection. So we are given the delta connection. That is, we are given the value of the resistance R12, R23 and R31, which are connected in delta, and we are interested in converting it to star. So we will make a star connection between these 3 terminals, that is between the terminals 1, 2 and 3.
we are making one star connection. So if we are converting this delta to star, it means that these values will disappear and this value we have to find out. So with the help of these three equations, we can find out the value of R1, R2 and R3 using these three formulas. And in order to remember the formula for R1, we find that this R1 is connected between the branches R31 and R12. So the formula of R1 will be equal to product of these two divided by sum of all the three resistance, as we can see from this formula. That is, the value of R1 is equal to R12 into R31 divided by sum of the resistors. Similarly, for finding the value of R2, we will have to multiply these two resistances. That is, the value of R2 will be equal to R23 into R12 divided by sum of the resistors. Similarly, the value of R3 will be equal to product of these two resistance divided by the sum of the resistance. In this way, we can convert any delta connection of resistance to star. In the next lecture, we will discuss star to delta connection.